What I was saying is we plan to cover points like deploying Julia applications on Kubernetes and leveraging Kuber.jl package for the same, enabling deeper integration flexibilities in context of application building. Some examples will try to show on deploying a HTTP server, deploying and managing a pipeline of stages, orchestrating the stages, etc. We would like this session to be interactive, so please feel encouraged to ask questions. We will either address them right away or at the end of the session. Quick intro about our presenter today, Tanmay Mahapatra. He's a principal software engineer at Julia Computing. He's an early stage Julia contributor and has authored several packages. He is also one of the lead developers of our flagship product, Julia Hub. It's a cloud tool. It's a software as a service SaaS tool for all things Julia. So folks on this call who are new to Julia Hub or have not looked at it or have not explored it, I would suggest please right after this session do log into juliahub.com, sign up there and see if you find it interesting enough. With that, I would like to request Tanmay to get started. Thank you, everybody.
Really?
Tanmay, you are muted.
I'm sorry. I was talking. No, yeah. Okay. Hi everyone. Welcome to this webinar. Today we're going to see how we can build Julia applications that have deep integration with Kubernetes. So all the material, including the slides that I'm going to use today, are in the repo, the link for which I have posted on the chat. Please feel free to clone it and access them directly if that works better for you. Let's go ahead.
Problem. They have to pay a lot of money to get people.
All right. So briefly, the things that we're going to cover today is to start with, we're going to briefly understand what Kubernetes is. I think most of you will be knowing already, but we'll just touch upon some of the important points that are relevant to us, and how Kuber.jl lets us interact with it. We're going to see how the APIs that Kuber.jl provides work. There are basic APIs like get, put, delete that let us manipulate entities on a cluster. And there is also the watch API that lets us monitor entities and get events for anything that changes there. So we're going to see all of those. And the way we're going to explore the APIs is via simple examples first. So we are going to first build an example that deploys a web server into the cluster. That's a very typical example that people use. We are going to do that using Kuber.jl. And then next, we're going to build slightly more involved application, which is a demo search server. It will have multiple stages, and we will build something that deploys all the stages and manipulates it entirely inside Kubernetes. So it will have the pipeline will consist something that will crawl the sources, download them. Just a moment. I got a comment that the repo is not accessible. It's private. I forgot to open it up. I'm sorry about that. Give me a moment. All right, it is public now. Everyone should have access. Very sorry about this. Okay, let's get on. Right. So the example search application will have a pipeline to that crawls sources, downloads them, and then indexes them, and then starts a search server using that index. The search server will serve REST APIs that we can query, and we'll see how we can update them, update the index periodically as well. That is, run this process which does this over and over again on the cluster. We should have enough time for Q&A at the end, but as Sushil also mentioned, please feel free to send your queries over the chat anytime. I'll be looking at it and I'll see if I can answer them as I go on. All right. Let's see. Kubernetes and how we use Kuber.jl. So first, what is Kubernetes? Kubernetes helps us deploy containers and manage and scale them on clusters. It sounds simple, but it is actually quite complex if we consider all aspects of it. And Kubernetes makes all this quite a lot easier for us to deal with all these complexities. The APIs that Kubernetes provides are open and they're unified and extensible. By this, I mean the APIs are uniform in the way they act across entities. And it is extensible because it allows us to plug in our own custom entities into Kubernetes and extend the APIs to manipulate them in the same way as any other thing that exists in the cluster. And this is very powerful because that lets us use all the existing tools out there to do other stuff with it. And it also lets us integrate with other stuff on the cluster which someone else has built easily. There are many popular distributions. Some of them are EKS, which is available on Amazon, AWS, and GKE on Google, AKS on Azure. And from Red Hat, there is OpenShift, which can be installed on any cluster, even on private clusters. And then there are other implementations, other distributions like K3s, Minikube, and MicroK8s, which are small enough to be deployed on laptops. And some of them are also production grade, so we can actually use them in production. We already have one example of using Azure with AKS, which is using Kuber.jl with AKS, and it is available on this at this URL. Some reason I'm not able to click on this. Yeah. Take a look at it if Azure is something that you work with. For the things that I'm going to do in today's demo, I use something called KubeADM. KubeADM is provided at this location from Kubernetes.io. But it actually does not matter what cluster you use. The examples here should work regardless of the cluster that you use. All right. What is Kubernetes under the hood? It helps to keep a mental model of what the API does. So simply put, Kubernetes is a combination of a state store that stores the desired state of entities and a machinery that tries to match the current state to the desired state. So the K8 is the Kubernetes APIs. Let us create entities in the state store and manipulate them to the desired state that we want. And it also lets us query the current state. And all the while, the machinery, the Kubernetes machinery, which is running underneath, and they're called controllers, they're acting to bring the current state to the one that is desired. This simple mental model is very useful in understanding what the APIs do. So with that in perspective, let's see how Kuber.jl works. So Kuber.jl is a Julia package, and it provides APIs to manipulate and query the state store, the Kubernetes state store. It basically implements the REST APIs to the API server of Kubernetes. So the APIs follow the familiar verbs and entities paradigm. So we have verbs like get and list that work on entities on the cluster. So we can use get and list to examine the entities, and put to create new entities, and update to manipulate, and delete to destroy them. And there is also watch API, which I mentioned briefly earlier, that lets us monitor, that is watch for changes in the entities, and we can subscribe to events for any change that happens there. Let's get on to use to understand more with a simple application. I have recorded this on using a screencast, and I prefer to use that just to save time. So this is a screencast of using Kuber.jl to deploy and watch Nginx server. Okay, let's start. Just give me a moment to expand this up. All right. So so we start up Julia, and as usual, we start by using the package, and we create a KTS connection. By default, the connection is made to a kubectl proxy. So here I'm not specifying any server or any authentication tokens or anything. So it has connected to a kubectl proxy that is running on my local node, so which is running at port 8001 on my local host. That's the default, but of course we can provide more details here to connect to a real cluster directly. Once we have the connection, we create a pod. Okay. So here we're creating Nginx pod, and you can see the familiar JSON format of a pod spec, and this API, Kuber_obj API, that parses the JSON and gives us a Julia instance, Julia struct instance. And if we examine the type of the Julia struct instance, we see that we have got a pod from the core v1 API set. Okay. So Kuber.jl has the API includes the API API set generated, default API set generated in this submodule, and that's what is used by default. And it allows us to switch to any other API set also. But in this example, I'm just using the default. So right now we have a Nginx pod instance, and I also go ahead and create a service, Kubernetes service, to expose the Nginx port onto the node so that we can access it. So if you see, the Nginx pod exposed a port 80 from the container, and the service maps that port 80 to a node port 30382. The node port is opened on my machine so that I can query it. Right. And since I'm running on a single node, I'm using the node port instead of load balancer. On a cloud service, you will probably use a load balancer. There is a question, why am I not using the latest Julia version 171? Of course, I could have. It will work with 171 as well. I just happen to use 164, 165 because that's what I have been using for some time now. All right. So what we have created till now, the pod and the service, they are not on the cluster. They're in the Julia session here. They're instances of Julia structs. So we have to put them, call the put API to create them on the cluster. So let's go ahead and create the service first. So this invokes the put API. Now the service is created. Once the things are put, once an entity is put, we can also query them. So using the get API. So if we do a get on the service that we created, get of a service named Nginx service, we will get the instance of the service, and we can access the details. And if we get the node port out of that, we can see that it is the exact same value that was requested, right? So why this is relevant is if we had not specified the node port here in our spec, Kubernetes would have assigned a free node port, and we could have queried what node port was assigned by doing a get. But for the demo, I specified a free node port, which I know is available on my node, and I'm going to use that. But for the Nginx thing to Nginx service to work, of course, we must put the Nginx pod onto the server, and that is what is going to actually serve the HTTP request. But before we do that, let's set up a watch on the pods to see how it reports events. So we'll start a watch task in the background that will monitor pods. So here is the watch tasks. If you see, it monitors all the pods, and we get events in the stream. And for every event in the stream, we extract the object that is there in the event. And since we are watching pods, we will get the pod object. And we print out the pod condition, pod status, along with the name. Okay. So we'll keep this running in the background. And let's now start the pod. Okay, so once we put the pod, we see that our watch task back in the background prints out the pod status. So the pod was in pending state for some time, and then now it came into the running state. Okay, so now both our pod and the service is created on the cluster, and we can now access our HTTP server. So we'll use http.jl and fire a request to the port, and there we go. We see the familiar welcome to Nginx page. So yeah, so this completes this demo. Of course, we need to clean up. So let's go ahead and delete what we created on the cluster. Yeah, that's done now. So what we saw is how we can use Kuber.jl to interact with Kubernetes, and how we can deploy and watch entities. All right, if there are any questions at this stage, I'll pause for a moment for you guys to post. If not, let's go ahead. Yeah. So now let's get on to the next example, which is building a search server on Kubernetes, which is slightly more complicated. All right, so we are going to build a simple search server. It will fetch source code for Julia packages from GitHub as compressed star bundles. It will extract them, and it will index them using this package called Google Code Search.jl. Google Code Search.jl is a wrapper over the Google Code Search utility. It provides Julia APIs to use that to index things. And that's available in this repo. You can see more details of how to use that here. Google Code Search also provides REST server, which can serve APIs over that index it creates, and we are going to use that as well. So we have done a few things to simplify the search server. We are not going to build a full-fledged search server here. Our main goal is to see how we can integrate that to Kubernetes. So we have simplified things to use pre-downloaded source bundles, and we're not going to actually download from GitHub. We are going to pick them up from the file system just to save time and uncertainties of the internet. And we only have a few source bundles to work with so that we can see the results quicker. And while indexing and re-indexing, we will not do any incremental indexing. On a real search server, you will actually see what is changed and only do incremental indexing. But in our example, we're going to rebuild the full index every time. And as I mentioned, we're going to use the search server that Google Kuber.jl provides. So with these simplifications, let's look at some more details on how to do things. Sorry. So I'll open the source code, which shows how the search server itself is built. All right. So this is the implementation, and so we have a set of paths that we deal with. The inputs contains the pre-downloaded source bundles that I mentioned. So this is our GitHub equivalent. So we are not actually going to go to GitHub. We are going to go to this folder and get stuff to index. And we simply we simulate a download from inputs into the downloaded folder. We simply copy things from inputs to downloaded folder to simulate a download. And what is downloaded is then extracted onto the extracted folder, and then we index those onto the index folder. We have a fetch sources method that downloads the source bundles, and which simply copies from inputs to downloaded. And we have extract sources that will extract whatever is available in the extracted folder. And we have index sources, which will index whatever has been extracted. It will create a indexer context from Google Code Search, and then pass each of the paths to be indexed to that to create the index. And finally, we have this run search server method, which will again launch the Google Code Search search server at port 5555 to serve the index that it created here. And all these methods, they before they do their stuff, they clean up whatever was done earlier. So extract sources will clean up the extracted folder and then extract, and indexer will clean up the index and then re-index. So it's very simple. So we have just few methods for each task of the pipeline, and a method to run the search server. So what we saw now is the core of the search server, okay, and the indexer pipeline, and the methods that we have for each stage of the pipeline, and there is a final method to start the search server. Next, we should see how to put this all together into something that we can run on Kubernetes. So to do that, we'll have to first build a container image that we can execute on the cluster. Because Kubernetes will run container Docker image. That image should provide a way to execute the pipeline stages, and it should also have a way to run the search server, and we should be able to re-index whenever we want, rerunning all the pipeline stages. So we have implementation of all that. Let's start looking at the Docker file. The Docker file is really simple. We start with the Julia image, and we copy over the project and the manifest and the sources. And then we do a precompile of the sources, and then we set up the entry point to this file named main.jl. Let's see what main.jl has. So main.jl provides a way to run each of the pipeline stages. Okay. So it begins by setting up the project environment, and then it includes utils.jl. Utils.jl is what we saw earlier, and it has the implementation of the indexer pipeline stages. This is what utils.jl was, right? So it includes that, and then it looks for the stage that it has been asked to run in the args. So we must provide an arg mentioning what stage to run, and it runs the appropriate stage. That's all it does. So with this, what we have seen, just to remind ourselves, is what the container image that we built is capable of. So it can run any stage of our pipeline, and we can deploy it on Kubernetes. What is needed next is something that actually runs it on Kubernetes, and that is implemented in this file, which is k8sutils.jl. So here we start using Kuber because we want to integrate with Kubernetes, and we create aliases for the types that we're going to use. So here we are using a pod and service, pod list, and watch event, all from core v1 API set. Okay, so we create aliases for those, and then we have some wrapper methods over what Kuber.jl provides. The wrapper method over put and delete to make things slightly easier for us. In delete, we're ignoring not found exceptions, and for put, we have this k8s run, which looks at the type of entity and calls the method appropriately. Simple aliases. And then we have this run. We have this method, k8s run pipeline command. This method can run a single command, single pipeline command on Kubernetes. What it does is it creates a pod using the container image that we created earlier, and it provides the relevant command as an argument to it. Yeah. It also mounts the work folder here, so that our code knows where it can find stuff and where it should create stuff. And then finally, it deploys that onto the cluster. It's very similar to how we ran the Nginx pod. Right? So to run the fetch sources step, we just run that method with fetch sources of the command. And similarly to extract source, to run the extract sources step, we run it with extract sources command, and so on and so forth. Right? We have a separate method to run the search server. The reason it is a separate method is because we need to create two different things. One service along with the pod, similar to what we needed to do for Nginx. The service is necessary so that we can expose the port out for us to be able to access. So here, if you see, we are exposing the port 5555 to a node port 30,005. And the pod looks very similar to the other pods that we have created. So we run the same image with the command, which is run the search server. Finally, we have a delete search server method, which cleans up everything. Okay, so until now, what we have seen are methods that can deploy each individual step of the pipeline. But now we need a way to advance from one step to the next. So this advance method does that. So given the current stage, right? So given the current stage, it knows how to advance to the next, right? So if we are starting, then it sets the stage to fetching and launches the fetch stage. And if we were fetching and we are done, then we will extract. And if we are done extracting, then we'll index, and finally we'll run the search server. And if you notice, before advancing to the next step, it cleans up the previous step, right? So before we index, we clean up the extraction step. It has finished, so we clean it up. So this is what advanced does. The can advance method here is used to check if a stage is done, and we can advance to the next. It's very simple, just a few conditions here. And finally, we have this k8s update search server method that does it all. So it starts by watching the pods, right? It initializes the pipeline by starting with the init stage. And whenever something changes, right? Whenever something changes in any of the pods that we created, it will advance it to the next step. It will check if we can advance, and if yes, it will advance it to the next stage. And it knows we are done when we are in the running stage. That is, we have finished indexing and we have started the search server up. That's everything is done. And it prints and completes it. Prints a complete message. All right, so now let's see this in action. Again, I have recorded a screencast. We'll go to that. All right. So we start with the same project. And so let's now deploy our search service. The first time it runs, it's going to do the indexing and download everything, do the indexing, and bring up the search server. And as it does it, as it goes to the stages, it's going to print each stage. So keep a note of how it progresses through the stages. So we included our file and then started the process. So we are seeing, you can see the fetch running now. And after some time, extract will start. Extract is pending. Now it is running. And once everything is extracted, the indexer is going to start. Yeah, indexer is starting. It's running. And now once that is done, it will start the search server, and everything is complete. Now that that is done, and our search server is up, and the port is exposed, we can query it. So we have a simple method in one of the other files called Query.jl, which has a simple REST call to the search server. If we use that to query something that we indexed, we should see some results, and it will print out the source code where the term YAML was found. And we indexed Kuber also. So if you can notice everything, if we search for Kuber, we get sources from Kuber.jl. And if we search YAML, we'll get sources from the YAML.jl package. If we search for something that we did not index, we will not see anything. Okay. So now this method k8s update k8s the indexer method that we ran, which ran through the pipeline, that can be run again and again. And if we run it once more, it's going to re-index everything and then restart the search server. So let's see what happens if we start it again. Yeah, so now it's starting. We see a search failed message here. That's because we stopped the search server before indexing. As I mentioned earlier, we are not doing incremental indexing, so we are doing a full indexing every time. So we stop the search server, and that's when it prints the search server failed. And then it will index everything as before, and then bring up the search server again. So this is exactly same as what happened earlier, if you notice. Yeah, so it's done. The search server has been brought up again on the new index, and we can query it again with this time with different package that we have indexed, and we should see some result. Yeah. All right. So now we can clean up. To clean up, we just delete and then stop. All right. So that was the example. So what we saw, just to recap, what we saw now is how to run, monitor, and manipulate applications entirely on Krig on Kubernetes. In the demo, I did run the Julia file outside of Kubernetes in a Julia REPL, but it is possible to actually run that itself inside the cluster. Nothing prevents us from creating a container, that including that in the container and running that itself in the container. And we can do this whole thing, deploy this whole thing in the container, and it will be a self-running thing, right? So it will keep running over and over again, re-indexing and redeploying the search server. Of course, the search server itself can be vastly enhanced. This demo only showed a very small part of what can be done. Some ideas to how to extend the search server. So we can actually run this whole thing inside the cluster as a controller. So our small example, the K8s utils, can be enhanced to become a controller. So we can use custom resource definitions and build a complete Kubernetes controller using Kuber.jl. And there's a lot of opportunity to vastly enhance the search server itself. Only few ideas I mentioned, but of course, it can be done very differently and in a very different, much better way. So to summarize, what we went through today is to start with to gain a simplistic view of what Kubernetes is under the hood in terms of the API and the controller and how the controllers work to keep the entities as we desire. So that helps to keep a mental model while we build Kubernetes applications. We deployed a simple application using Kuber.jl APIs, the Nginx application, and we saw how we can monitor that. And then we saw how we can run a larger application entirely inside Kubernetes and how they can potentially monitor and manage themselves. Yep, that completes my presentation, and let's go and see if there are any questions. All right, I'll go through one by one. Yes, Thinncast was a good idea, somebody says, and sure, I have the cluster ready on my machine, but just to save time and avoid any wrath of the demo gods, I thought I'll go with the screencast. The next question was, do you have an example of doing the initial deployment task in a GitHub action instead of manually in a terminal? No, I don't have that example right away, but I assume GitHub tasks are finally API calls, REST API calls. So yes, it seems possible. There's a question that says, is there a way to manipulate the cluster itself? Oh, yes, of course. The API, by what I understand when you say manipulating the cluster itself is to manipulate attributes of the cluster, that is change something in the network, or attach a disk or something like that, yes, that can be done. The cluster itself is comprised of entities that can be manipulated by the APIs. And yes, it is possible if there are appropriate privileges for your ID. When can we expect Kuber.jl to support CRDs? It is possible now. Actually, we did some work recently. So the latest version of Kuber.jl allows the API implementation to be switched. We have not yet documented the process fully. I will put something up shortly. It is possible with what we have today. So it basically involves generating a new API set from your server, which has the CRDs deployed. And then you can switch the API set from what Kuber.jl bundles to what you have. Right. There's a question, cluster manipulation can include scale-up observers. Yes, potentially, yes. It will involve you interacting with the cloud APIs to launch new servers, and then you can have them join. So, for example, we had a cluster autoscaler implemented using this. So, yeah, it is possible. Just wait for a few more moments. Yeah. How about controllers done in Julia? So right now we don't have an elaborate framework for building controllers like what you have today in Go. But what I showed is basically the essence of what a controller is: watching and then reacting to the events. That's what controllers do. But Go has much more extensive framework, which has some caching and stuff like that. So which are currently not there. But if you have a very simple controller to be done for a single application, it should be reasonably efficient and easy to do in Julia.
Looks like we are good for today. I don't see any further questions.
Yeah. Thank you, everyone, for joining today.
Thank you, everyone. The recording of this webinar would be available under resources on juliacomputing.com website. Do write to us at sales@juliacomputing.com regarding any of our products or any help with your Julia projects. Thank you all. Have a good one. Bye for now.
Thank you. Bye.